Welcome, everyone, to our third episode of CHBA's webinar series, Working with Modular. I'm Frank Lohmann, CHBA's Director of Building Science, and together with Kathleen Maynard, CHBA's Senior Director of Building Innovation, we will host today's webinar. Kathleen and I are part of CHBA's technical team that supports the CHBA Modular Construction Council. By the way, most of the images you will see in today's webinar are from factory builders on the Modular Construction Council. And we're joined today by three guest speakers, Simarjit Bains and Rick West from Triple M Housing in Lethbridge, Alberta, and Mohammed Al Hussein from the University of Alberta. Before I introduce them in a bit more detail, some housekeeping. We have muted all participants so that there are no distractions. We have had over 300 registrants for this webinar, so there's a lot of you there. We will, however, try to make the webinar a bit interactive. Firstly, you can ask questions throughout by writing them in the question and answer panel. Maybe let us know who you should or who should answer, who you would want to answer that question, so it'll be easier for Kathleen in the end to moderate the Q&A session at the end. We may answer some of your questions live or directly in the Q&A panel during the webinar or in writing after the webinar has ended, because we have a hard stop today at 1. Secondly, we will have a few polls for you. And when we launch a polling question, you will see a response function pop up. We'll try that right now with the first question on the primary region where you and your business organization operates. So you should see the panel now, the poll window, and please select the region that you're doing business in. And Kathleen will see as the results come in. And when we have most of the questions responded, she will present the results. And there are the results. So we see that we have good, very good participation from Ontario and Quebec, almost 40%. And then BC and Prairies each around the 25%, and some from the Atlantic and some from national organizations that are active nationally probably, and even one from outside, or 1% outside Canada, which is great. Thank you so much. So we can close the panel there. Also, please be aware that the webinar is being recorded, and the recording will be available on the CHBA website, maybe tomorrow, maybe next week, Monday, in case you can't stay to the end today or you want to listen to a certain portion again. We will also post the slide deck to this webinar on the CHBA website on the modular construction page, which is at the bottom of the slide there right now. You are probably all experienced in Zoom and Teams and WebEx, just to remind everyone that you can manage the size of your screen by sliding that dividing bar on the side. And then let me say a few words to the webinar series itself. The entire webinar series consists of 6 webinars that will be delivered between April 22 and April 23. You can see the titles and the dates on the right. And those of you who've joined us for the previous webinars, you will have noticed now that the number and the webinars and their order and their dates have evolved somewhat. But the purpose of the Working with Modular series is to provide information on the modular construction sector in Canada. We hope that code officials, municipal planners, housing providers find an interest in what we present, as well as builders who are currently building homes on site rather than off site, or builders who have started experimenting with modular construction. We also hope that federal government departments and other stakeholders engaged in the residential construction industry find the information useful and applied in their work so that modular construction gets the credit it deserves. Let's try another poll right now to find out how well each of the groups I just mentioned are represented in today's audience. There you go. Thanks for Kathleen for bringing that up. So you see the choices there, and pick the one that's closest to your area of business activity. And when the results have come in, we will see this. At this point, while you're selecting your business area, I'd like to also acknowledge the support of the Canada Mortgage and Housing Corporation in the development of the webinar series, as well as the Altus Group for their work in the project. And then we'll see what comes in as a result. Okay, so the site builders, renovators, developers are the majority group, which is great. They all want to learn about the factory process. And then we have a few modular builders, that's great, and a good mix, very homogeneous code officials, government, architects, engineers, and product manufacturer suppliers. That's great, good for us to see, and even a few municipal planners. Thank you so much. This is good to know. So here is a quick roadmap through today's webinar. In the first part, we're getting a real bird's eye level overview of the factory construction, and then we dive into every step in more detail. And the second part, Mohammed's presentation, we will learn from a case study where the efficiencies in the factory process come from. Finally, and last but not least, I would like to introduce all our speakers today. Simajit Bains is the Vice President, Manufacturing at Triple M Housing. She leads the operations of Triple M Housing, the manufacturing facility in Lethbridge, and oversees safety, quality, production, customer service, and design. Sim has over 20 years of experience in the industrial and construction sectors, and in 2018, Sim was awarded the Top 40 Under 40 Award by Lethbridge Chamber of Commerce. Rick West is the president and CEO of Triple M Housing and has been with Triple M since 1996. Rick was the president of the Canadian Manufactured Housing Institute from 2015 to 2017, and Rick received this year's CHBA Member of the Year Award. Sim will present the factory tour, and Rick will be available to answer questions at the end of the webinar. Then our third presenter, Dr. Mohammed Al-Hussein, is professor in the Department of Civil and Environmental Engineering at the University of Alberta. He's also NSERC Industrial Research Chair in the Industrialization of Building Construction and a member of the Nasseri School of Building Science and Engineering. Dr. Al-Hussein's research has been published in over 300 scientific journal articles and conference proceedings. It's probably a few more now because we used the same intro for him last year, so probably 300 plus now. So with that, before Sim will start the factory tour, we would actually like to ask you two more questions. So Kathleen, you can bring up the third polling question. What is your primary interest in learning about the factory construction process? We have a few choices there for you. I'll give you a few seconds to select, and then we'll look at the results. And this might help Sim to focus on one or the other aspects during her presentation. And when we bring up the results here, get ready for another question right after. Okay, looks like we're gonna have result. Oh, that's very even. Excellent. So you see there may be a slight more sustainable construction, but otherwise I would say this is very, very even. Cost savings, schedule, sustainable, and even other reasons. We didn't want to give you a choice to write all this down because we just like to do this so that Sim has a bit of an idea of what the audience is looking for. Then the next question, I think we have another question. Yep. Have you been inside a modular factory before? Very simple question. Yes or no, just to know. Because if we're all modular builders here, then Sim can talk a lot more detail, but as we just saw from the participants' professions, we'll probably have a majority here on people who have not been in a factory, or at least not very often. So we'll see what the results show us. Excellent. So the majority has never been in a factory, but there is a good portion that has been there before. So Sim, with that, I pass it on to you so you know what your audience is. Take it away, and I'll pass on the slides for you.
Perfect. Thank you, Frank. Yeah, so we thought it would be interesting to show you a typical modular factory. So we have some footage going on the screen right now. This is Triple M Housing. It's located in Lethbridge, Alberta. The whole site is 31 acres. The main facility is 192,000 square feet. As well, we have a separate building for a saw shop and welding shop. That's 12,000 square feet. So we cut all our components on site for lumber, as well as we do all our steel frames on site here. We have over 400 employees. And as Frank mentioned, we do everything on site. So our 400 employees include our production employees, as well as our design and engineering team, our sales and marketing team, purchasing, quality control, safety, as well as customer support and warranty. We can go ahead and move to the next slide, and we'll continue on these points, Frank. So the factory inside, this is really the interesting part. We have 21 workstations. And then at the very end of the factory, we'll show you where we do our drywall overflow. In modular construction, we're building inside out versus outside in, just because we are in a temperature controlled environment. You're going to notice as the drone footage is going on the screen, we do a lot of things that help efficiency. So we'll go ahead during floor construction, put in large fixtures like tubs and showers or hot water tanks. We'll even, as this drone is coming across here, you'll notice that there's cabinet packages that are being put in. The reason we're doing that there is that we really want to make sure that anything we don't have to fight through a doorway, anything that's easier on our employees because we can use forklifts or other means to lift these heavy things in, we'll do it there. And then from a quality side, it doesn't damage the inside of the building if you're doing it where it's most accessible. As we go through this, it does work on a main assembly line. So as I mentioned, we have 21 workstations. And at each of these steps, we have different crews that are working on that unit at that time that's specific to their skill set. Once we do have our walls set up and our floors set up, you're going to see that the roof has been put on, and we do build our own trusses on site. So our floor trusses and our roof trusses are built. We have a team here. As I mentioned, the saw shop will cut the components and our truss equipment will put that together. As we're going through the roof construction, you'll see that the insulation is blown in. We've got cardboard stops. We'll put the sheeting, the protective cover. If it's a shingle roof, we'll go ahead and shingle it. Now we're going into that spot that I talked about, more into our drywall overflow. So in factory construction, you can do drywall within the facility, so mud and tape as well as paint. Really, the goal is to finish the home or the product that we're building to as much completion so that when it goes to site, there's very little that the site construction or the foreman has to do. When these houses are finished specifically here, at the very end of the line, they'll go through a rigorous inspection process. We'll also do, electrical tests to make sure that no wires have been hit by fasteners. We'll do a water test to make sure that there is no plumbing leaks. We'll have our quality team just go through and make sure that it'll meet our standard. And then we'll go ahead and load in any ship loose package that may be required, that at site they can quickly go ahead and set up the home, put services to it, and bring it to the customer. Roughly start to finish, from when we start building that floor to when it's done, it can take as quick as 10 days. And if it is something that's a drywall product that we're painting, it can take up to 21 days. So very managed, well within the factory parameters. The construction process, because we are building everything at workstations, we're really able to create an airtight building. We'll talk a little bit more about that as we go through the different steps. So overall, these are the steps that happen in the factory, and we'll talk a little bit more about them in detail. It really starts with sub-assemblies, then we go into floor construction, wall construction. We'll talk a little bit about the mechanical installations that are happening, the roof construction, then the interior-exterior assembly, the quality assurance programs and processes that happen at the inspection stage, and then shipping. So we'll go ahead and start with sub-assemblies. So for sub-assemblies, what we really want to do is our main assembly line, we want to make sure that that is moving at a consistent and steady pace. So sub-assemblies is anything that we can do off the main assembly line. So even prior to floor construction, a sub-assembly for us would be, if it needs a welding frame, we'll go ahead and have that steel frame built ahead of time. Our potable water lines, our venting, our ducting that goes in the floor, we have blueprints already designed, so we can go ahead and give that to our crews to go ahead and do that sub-assembly ahead of time. So if those sub-assemblies are done offline of the main assembly line, then when we go to do the main construction of the floor, these things are not slowing down the process, and we can manage and control the pace of the floor, which really is important when we have delivery schedules, customers who have already booked things on site, that we can make sure that we're going to deliver that product on time out of the factory. So these sub-assemblies are happening even before we go ahead and start on the floor construction. So moving to the next slide.
Sorry. Yeah.
Thank you, Frank. So in floor construction, we are going to be building based on what the customer request is. So our floors, they can be truss floors or they can be joist floors. And you can see in these pictures and even in the next picture, Those sub-assemblies, you can see that the ducting's in place, the venting's already put in the floor, it's been insulated, and those workstations ahead of it, that's where we are going to start sheeting. If we want to put floor covering on it, we can do that at that time. With having the option between joist floor or truss floor, it's really up to the customer what they want and what kind of foundation they're going to be putting that product onto. Sometimes it can go on a concrete foundation, sometimes it's going to go on a basement, sometimes it goes straight onto piles and there's a steel frame under the floor. So it's really up to the customer, and that's how we'll construct that floor. As the floor is being constructed, we also will be, once it's insulated, the potable water lines have been put in, we'll put a quick air test onto it at that time. So in the modular factory, we really want to make sure that if there is an issue with the water lines or if there is a leak, putting a quick air test on, we'll put it 100 psi for 15 minutes and make sure that it holds pressure. If it doesn't, this is the time we want to know. We will do another water test at the very end of the line, but at that point, you'll be damaging other things, and to do the repair would be quite complicated versus doing it right here and now. So in the modular factory, the quality assurance, there's a lot of checks and balances in place because we want to make sure that the product is going to meet the requirements on site, as well as we're building to the National Building Code. If it's going to a certain province, they may have other codes that we need to meet. So anytime that we can do those checks, we will be doing that. We can move on now to the next slide. After the walls are constructed, we'll do wall construction. So walls are built on jigs off of the main assembly line. So this is really good. It's easy to control what we're building. As well, we can lay vapor barrier across the entire wall structure to make sure that we can manage the air tightness and quality in the building envelope. So often these walls, you'll notice in the pictures, and hopefully you saw in the drone footage, they'll have tails of vapor barrier or poly, so that we can go ahead as we're building the walls, we have that continuous poly, and then we go and put it on the floor. We'll have those tails that we can go and seal together from wall to wall and then ceiling to wall. Working on the wall jigs from a quality perspective, all these components are cut precisely in the saw shop and they're done ahead of time. So that each of those pieces are repetitive and they're at an exact measurement. You also see there's some insulation that's been put in on the header to prevent any thermal bridging. Those are things we can do on the wall jig. We can go ahead and also fasten on the drywall and the paneling. Once those walls are built, we'll use a lot of overhead cranes. So from a safety perspective and to minimize injuries to our employees, any repetitive strain injury, in a factory environment, that's really easy to do. So a lot of times, in most of the factories, you'll see a lot of overhead cranes available. Moving along, so in our interior walls, those are also built on jigs, and then you can go ahead and make packages per home or per floor so that everything that's being built is going to match the floor that's being constructed. So we went through the process of how the floor is constructed. Once that's done, we go ahead and put in the interior walls. You can also see in that picture, there's a cardboard box. That's probably a hot water tank or a furnace. Like I mentioned, we want to put that stuff in now and not have to fight through doorways afterwards. You can see the gentleman on the side here. That's how easy it is to move these walls, right? When you can use the cranes and the lifts, he's really guiding it into place. So from a labor efficiency, it takes one person to do that, and then we can go and fasten it into place. Here you're seeing just how big these walls can be. In our facility, we can build them 76 feet long. So it's a fairly big, heavy structure. Again, you're using the crane power to put them onto the floor, and you can place them and square them up precisely. You can also see that continuous vapor barrier shown there as well. So on to mechanical installations. So we've kind of walked through the processes. There's some things that can be happening concurrently. Here you're seeing electrical panel that's already been pre-wired. So that is also working off an electrical distribution schematic. So what we can do, we know the size of our homes, the size of the structures. We can then go ahead and measure how much wire length we're going to need. We can also have defined exactly where those power outlets are going to be, where the switches are going to be. So we'll go ahead and do that and pre-wire our electrical box. I'll talk a little bit more about what happens to that when we get into roof construction. The other thing we'll do is those tubs that have been put into place, we'll actually go ahead and hook them up. So in the floor construction, you saw in the sub-assembly that the water lines are already done ahead of time as a rough-in. Well, now we can actually go and hook it up to the shower or the tub. We can also make sure the furnaces are ready, the hot water tanks. So any of those things that we can do at this point, this is when we will do it. So roof construction is really interesting in modular. So the roof trusses, we do have truss equipment in our factory, and every factory is a little bit different. Some people will outsource them, some people will make it themselves. So we here, when we do our roof construction, we will go ahead and lay out our trusses and our rails, and then we will go and make sure that we've fastened the gyprock. We will then go ahead and mud and tape it. We will make sure that any light fixtures that are showing on our fixtures are already pre-drilled out. And we will go ahead, mud and tape and stipple it. So the ceiling, when it's being constructed, and the roof construction, when it is finished and being ready to be put on the home that now has its floor and walls, it will have the final ceiling finish on there. So this is interesting because a lot of times that could cause delay later on when you're doing site construction, because you have to make sure that the room's all clean and clear, whereas we're stippling that ceiling as part of the roof construction. This is also the stage that electrical panel I was talking about that's pre-wired. It would be placed into the roof trusses before we go ahead and crane that entire structure onto the building that it matches. So moving on. So on the one side there, you can see that stippled roof that's being ready to be placed onto the building. There is different types of roofs we do. We can do two-piece homes where it's a hinge roof. And then on site, we'll go ahead and bring that structure together. We can do flat ceilings, cathedral ceilings, but really at this point on the factory process and the assembly line, what we're trying to do now is put the lid on the box. So the roof is coming on. So now you got your floor, you got your interior walls, you got your exterior walls, you've already loaded your tubs and showers and hooked them up, and now you come and put the roof on. So in interior and exterior assembly, so as the product is now working through various workstations, there's a lot of things happening inside the structure, outside the structure. One thing you'll notice in this picture is that a lot of our factories work off of scaffold systems. This particular shot is showing a moving scaffold system. So as we move the workstations and we move the product down into other workstations, that scaffold system can roll along as well. And then we take a crane and move that last scaffold back into the first position. As we're completing this home, we'll be going and doing we'll take that electrical panel, we'll drop it into where the mechanical room is going to be inside the house. We'll spray foam where that opening is. We'll go ahead and run those wires. We like to run the wires in the ceiling space down into the wall. So for each of the switches and devices it needs to go to. We will insulate around our eaves. We will do blow-in insulation. You have the cardboard stops put in to make sure that insulation doesn't fall towards the eave and it'll stay in place. We'll sheet the roof. We'll go ahead and shingle it. I can't emphasize how important safety is during the construction process. And the reason we use the scaffold system is so that we don't have anybody falling from heights, and it's easy for workers to be able to work. If the building structure cannot go up against a handrail system or against the scaffold, you'll see a temporary restraint, and you can see that sort of on that third roof structure where a temporary guardrail has been put in place. And again, that's to make sure that the workers can work safely. So in the modular environment, there's a lot of risk that is taken out because we can make it easy for the workers and make sure some of those the risks that can be hard to manage are controlled properly. So yeah, the home as it's moving down those stations, the outside of the building, it'll be insulated, finished for wiring and plumbing. It'll be sheeted. We'll put the building paper on, and then we'll put whatever the exterior that the customer has ordered and finish the home. So in this case, we're seeing some corrugated steel that was chosen along with some vinyl siding. You also see that the soffit's done. And in this case, the roof is done. Venting, you can see the vents are on the roof already. On the inside, a lot of factories will have their own cabinet shop. So building your own countertops, laminate countertops. You can also put in quartz countertops, which would be ordered through a supplier. So cabinets are put in as early on in the line that we can because they're often big and large. And then when it comes to finishing the inside, that's when we'll start putting in the countertops, putting in the sinks, placing the toilets, and starting to do that final finish inside that home. So really, when that product is getting to the very end of our production line, it is going to be as complete as we can be. Our goal is to really limit the amount of work that has to happen at site. Appliances will be put in, washer dryers, stoves, range hoods, microwaves, anything that we can do, we want to do it here. And we will also make sure that it is ready to transport. So we will put strapping if we think that there's, especially fridges and washer and dryers, we'll strap in front of them. So during transport, they don't vibrate or they don't move out or fall. So inspection is a very, very important part of the modular construction. So our factories have to be third-party certified, and these can be organizations like Intertech, CSA, QAI, and we have to apply for certifications. So in the housing world, you would apply for a CSA A277 or CSA Z240, Z241. There's another webinar that's going to go through more detail about what those things are. But really, what we want to do is go to a third party, present a quality assurance program of how we're going to make sure that we're building buildings that are going to meet code. And what codes are they going to meet? So these structures are having to meet the same codes that traditional site building companies would also do. So to the National Building Code, we got to make sure it meets the current electrical code. Different provinces and territories also have other requirements, so we'll have to make sure that they meet those codes. So when we are at the final end, our quality assurance department, they're walking the line daily at each of the workstations, and there is something we call a travel log. And at each workstation, there's a checklist to make sure that you are completing things and we are abiding by the quality assurance program that we had submitted. Also, quarterly, we do have our third-party inspection agency coming in and doing a check. And they'll do an audit on us and let us know if we are following our quality assurance program or if they want to see us improve in different areas. And that's really to make sure that the quality program and your certification is being used well and properly. And then we'll go ahead and label the home based on what it's being certified to. So there's some examples there. QAI, that's their A277 label. And those are found on the electrical panel typically. Also, when we're walking it, we do a punch list with our quality assurance inspectors, just like if you're taking possession of a home and you want to go and walk through and then see, where you want to see improvements. Our inspectors will do the same thing, and they will red tag anything that they don't think will meet the quality standard, and then we'll come in and make sure we take care of that before it gets shipped out. So for shipping, we really work hard at making sure when we're ready to ship houses that it's as easy as it is for the transportation companies as well for the site setup crews. The next slide here, you'll see that we'll even load any shipping package. So if there's anything that needs to be done on site for multi-piece homes, so if you need to have extra siding to make it look continuous on your end wall, that will be preloaded into the home. any things that might make your building overheight. If there's venting that sticks out too far up, we'll load that in the home. So we really want to make sure that everything that you need to do to set up your product is there. In a single family home that's being sent as a single piece, there's very little shipping package in there. Multi-story, there would be more as we do the connections, two pieces likewise. So we will do what we need to do to make sure that building, when it's ready to transport, is weather tight, because we don't want to see anything happening en route, as well that it is acceptable to transport on the highways. Transportation widths is really up to the provinces and the highways that it will be traveling. In Alberta, we're able to ship product 30 feet wide, 76 feet long. It's quite incredible to see that as a single piece moving along. If you've ever seen it on a highway, it's pretty impressive. And then when you're shipping it to BC, they have much more narrower highways, so you can't ship that kind of product there. When it does get to site, in modular construction, there is different things that have to be done on site to be ready. Some of it can be very, very non-disruptive to the existing site that you have. So here you're just seeing some pictures of auxiliary dwelling units, and you can see that there's an existing home already there, lots of mature trees, and we don't want to have to disturb any of that. So the site foreman there has cranes ready, and we'll use strapping and spreader bars, and we'll make sure that we do very little and try to keep that whole site intact and be as non-destructive as we can. Also for neighbors in that area, it's nice for them to see that product go into that backyard, and you're not causing too much disruption on the street over months and months of building it. Stick built, this is already ready to go. It gets set in place within hours, and all that equipment is gone. Some others, a little more complicated when it is a multi-story or multi-sectional. Again, a lot of crane work that happens, and based on what we need to do to set it up, these modules can get in place quite quickly though, and the inside of these boxes are complete. So the outside, some projects, to make it look more continuous, they'll leave it with just building wrap, and then once all the boxes are put into place, then they will go ahead and put that exterior cladding on. And it's done with quite precision. So the work that's done for foundations and the size of the structures of the boxes, that's why that quality assurance during the factory process is so important, because everything will just fit just very precisely, like puzzle pieces. Often they're referred to Lego blocks, but truly it's amazing how quickly these things can go on. So yeah, and here's just some pictures of finished product in the modular world. Really, it can be houses. We've heard a lot and seen a lot on the multi-story product, dorms, hotels, affordable housing. We also have townhouses that are done with modular, and here's some examples from various builders. So lastly, I think one other thing to really be mindful about when we do talk about modular construction, because we're building in the factory and we're doing it as finished as we can, the design and engineering and the permit and approvals and the material procurement have to be done up front. Whereas, when you look at the on-site typical construction schedule, you do have a little bit more liberty of when you do your material procurement, because it's okay that if things are happening as that structure is being built, you can make those decisions later on. In the factory side though, but being able to have all that stuff up front and having those signed off as specifications, then when we're building the modules in the factory, at the same time, the site can be being worked on concurrently. So that's a really big time savings overall, when you can be building the modules and doing the site at the same time. And then you'll go ahead and set it up at site, and do any site restoration that you might be able to do. So overall, when you look at the entire schedule, that's where you can really see the time savings, is that when you can do some of these steps concurrently, but also being mindful that some of the decisions that you might be used to making later on in a process have to be done up front to make sure that it is very efficient and those units are coming out complete.
Thank you, Sim. That was an amazing factory tour. And we'll have chances to ask questions afterwards, and Rick will have to answer them. Sim may have to leave us on time or earlier. So thank you so much. Before Mohammed will present his analysis of the factory process, probably get more into the details that Sim had in her last slide there. We would like to ask you 3 rapid fire poll questions. So get your mouse clicking fingers ready. Kathleen, if you can bring up the 5th question. In your estimate, how many invoices per year does an on-site production builder constructing about 500 homes a year receive? What do you think? Just click 1. Don't think much about it, because we have another question right following. How many invoices for all kinds of things, material and products, through a year for 500 homes on site? And when we have results, Kathleen will magically show us. Okay, so the guess is 80,000 wins the majority here, but there's quite a few, 160,000. Okay, so that's a lot. So then maybe some people in the audience that know. Next question would be, if you can bring up that poll, Kathleen, in your estimate, how much time does it take the office of that builder to process an invoice? Again, 3 simple choices. What do you think per invoice? How much does it take to process? And obviously in your head, with your own personal responses, you can now calculate what the top will be, but the results are, okay, 10 minutes. So on average, we said earlier, 80,000 in 10 minutes, so you can figure out what that time is. Now, the last question, and then I'll pass it on to Mohammed, is, but how much will the number of invoices be reduced when the on-site production builder moves 100% to in-factory production? So here are the choices: by 20%, by 50%, by 80%. And again, this is one example, but Mohammed will talk about that in more detail. But he will probably respond to our guesses. And the results are, oh, so we are optimistic here, 80%. That's great. So there may be some people in there who know something. Okay, perfect. With that, I'll pass it on to Mohammed, and Mohammed will now start sharing his screen, and then he will present his presentation.
Thank you very much, Frank, again, for the opportunity to come here and speak to your conference here. I'm just putting the presentation on a perspective. I hope you can see my screen at your end now. Kathleen and Frank asked me to focus on 2 things on this presentation. One is if a company transform from what they do on site, which I noticed that I think from the poll we had about 30% of the people around our site build, many production builders of a kind. And the second part of the presentation, I'll go into the factory and provide some overall view of efficiency in the factory. I took a great case example, a production builder in Edmonton for about 35 years plus as a stick framer, builders in the province here. Or site build or conventional, and then they decide to fully automate, and now they are 100% industrialized. So I try to look at what other hypotheses we need to put here to see what changes it happened to this organization, which is the production builder in this particular case. So we put 5 different hypotheses. Maybe the number of superintendent will not be as many. We look at the production rate. Can they produce the house in a shorter period of time? And the invoice, which is Frank was more interested in, and that's why he put the poll and asked the question about the invoices. When you complete, you have to inspect. Is there any impact of factory build in reduction of the number of inspections or the failures of inspections? And then the required or the need office space. So these are the 5 hypotheses I would like to share with you, which were based on actual case study, which is the one builder in Edmonton here. Because they move only the framing process, which is the panels, interior and exterior, and they put sheathing in the panels, and sometimes they put windows, tie-vac, and others. So they discover reduction about 97 days in the production of a house. So they used to take about 270 days, 240 days plus. Now it's under 145 days on average. So that increased their efficiency, or reduce 40%, if I call it, on the production of the house or building of the house. We start to look at what does it mean to this home builder. So we noticed that in this case, their abilities to produce 1.5 homes in any given patch of time. And then they can increase that to almost 2.5. So there's an increase of their abilities to produce homes on the period of time, which is 360 days. We start to look at the superintendent. We were told that on average, a superintendent will handle 15 homes at any given day. And we'll assume even the framing reduces the demand for the time that is required from the superintendent. We'll assume it's the same 15 days, 15 houses per patch. Once they finish a house, they'll assume within a day or two or a week, they'll receive another house to replace. So they will have 15 homes to monitor or supervise in any given day. With the reduction of the time, we discovered that the superintendent can produce way more homes, from 22 homes per year. They can produce about 37 homes per year because of the time it takes to build a house. So that if you look at the 1,000 homes, if the builder built 1,000 homes, with the assumption if the 15 homes per patch remains valid, they may need 47 superintendent. I think at the time they had way more superintendent than 47. And in reality, they could need probably 27 directly related superintendent to the work they do. If I look at this as production, reduction of the time to build, increase their abilities to turn over number of homes per year, a superintendent can increase their efficiency. I mean, there are more homes per year, about 15 homes per year on average. So in 5 years, the superintendent, or 10 years, the superintendent can provide more than 150 more homes than they could do when they are stick building on site, or they have to monitor the framing process. So this builder is only panelized. It's not what was presented earlier this morning. So if you look at that, so their efficiency could be the same by less superintendent, reduction about 41% of the demand for people to become a superintendent. They could do something else. And we need to see, okay, well, what does it mean? So there is a reduction of the number of pickup trucks. There is a reduction of the oil consumption by the trucks moving back and forth to the site, and which associated with a potential reduction on the CO2 emissions. This builder, I heard that they purchased a large amount of pickup trucks leased in one bill from GM. And if you go to their parking at the time, you can assume they're a dealer really rather than builder. So that 41% of reduction of the trucks, what does it mean? So they open their book and they show us their consumption of receipts from the oil or the gas these trucks build, and we discover they have about 22,000 liters reduction per year. So which means about almost 2,000 liters per month is being reduced by the fact that the superintendent do not have to travel for the scope, which was already given by the factory, which is the framing scope. We look at that in terms of CO2 emissions. We look at the performance of the vehicles they use. They're all new vehicles. And then the reduction of that will contribute to about 52 tons less of CO2 per year by the fact that there are fewer trucks needed or fewer trips needed to do the work they do. I'll jump into the permits and the inspections. There's lots of time it takes in terms of permits compared to what it is today. Inspections, on average, the inspector will visit 2 visits, and sometimes they visit 1 visit, and sometimes they visit 3 or 4. So the city, on average, they will probably charge for 1 or 2 visits, but any additional visits, the builders, they have to pay additional fee. And we discover it's about 8 inspections are required for the scope, which is being taken care of by the modular or the panelized company. So the 8 inspections today, there are 0 failure, if I want to call it. None of the inspections turn back with the red sticker, so it's all green. Compared to the past, they will have at least 1 extra visit, which costs some money. So there's a little bit of saving for the builders from the builder perspective on the amount of money they'll be paying for the inspections. The item I want to talk about here, which is the pool, shows this builder, when you look at the 5 years average, they would receive 160,000 invoices per year. So I ask him how long does it take. They tell me the invoice has been touched by 5 to 6 people within the company, from the front desk, copying, photocopying, moving, and manager, superintendent. And so all these, they look at it. Some of them will be seconds, some of them will be minute. And they said, well, on average, about 15 minutes. So most of the poll today said about 10 minutes, which could be valid. In this particular builder, they said, based on the discussion we had with them, a focus group discussion, they said about 15 minutes. So 160,000, 15 minutes, that's about 40,000 people time, office people time. And the addition, invoices cost money to process, to produce, because the trade, they have to certify, notarize the invoices that they paid their trade, they paid their material, and so on and so forth. On average, we've been told that each invoice will cost the sub-trade about $60. So you can imagine how many $60 are being wasted, if I want to call it. And that will be, the number of invoices will be reduced, because the combining 9 purchase order in one for this particular builder. Again, this only the framing. So that framing of walls and floors. So it reduces the number of purchase order from now to 1, which reduces the number of invoices dramatically. And I look at the poll, they said probably 80% or 70%. You might be correct if you move to a full manufacturer similar to the 3M, the one presented earlier. Yes, the number of invoices will be reduced by probably 90%, not even that. So I call the invoices as a hidden disease, and I see why Frank insisted that you want to ask these 3 questions about the invoices. So we look at this space. This builder was spread into 5 buildings. Then they sold the 5 buildings, built one multi-story building, and they've filled up 1 full floor. And then they discovered that they don't need it. That's way before the pandemic. And now they're occupying half of a floor. And I understand today they are even willing to give up half of the what they have of the floor. So if you look at that in general, they reduce their need for the footprint in terms of office space by 76%. Perhaps some of that office space translate to the factory, but this factory today is serving multiple builders. So if you look at the perception and the ratio, there's still a great value of reduction in terms of office space. And one can extend the effect of the office space reduction on the CO2 emission, the environment, and the cost of running these offices. So the second part of the presentation, which I would like to share with you here about the efficiency, and that's what Frank and Catherine asked me to look at. So we look today at a fully developed 3D volumetric model, which is 3M presented greatly, and thank you for that presentation. And the fly through the factory was an amazing, in my view. So I see what are the challenges. Sue mentioned here when you go to site, safety and schedule and so on and so forth. So I discover sometimes if you have multiple modules, when you have a multifamily and others, the schedule is really left for the superintendent or somebody on site to deal with the situation. In reality, the modules are lifted in minutes of time. So the schedule, I look at it as a minute-based schedule. And then also the people have different trade capacity or trade. So I specify the trade, who need to be what and when to be. So there's an ability to schedule based on space, time, and also qualifications of the trade on site. It looks like, well, this is like too much into complication, but it's really simple once you get into that step. So people want to know where they need to be at one particular point of time, and rather than moving around on site. The second challenge I discover inside the factory, there is a lot of manual work today. So in North America, we tend to rely on the same tools we use on site and make under the hood of the factory, which is really we're getting advantage of the space. But here I'm showing a floor which is being made, and I heard 3M, they can produce about 76 feet long. So to make a 76 feet long rim board, we try to mimic that into the animation just to express the way it is being made. So the timber comes into nominal dimensions of this way probably be 2 by 10, and they are 8 feet long or 10 feet, or you can get it a little bit longer than that, but you cannot get it at 76 feet. To make that full length, the operators they have to make gust plate them together, and then when it's long enough, that move back and forth. And there is, so when I look at the lean concept, all lean principles are somehow violated throughout this process, which is the animation shows. There is a lots of motions, a lots of transportation. You can see people moving back and forth. Perhaps some waiting time is being, and you drop things, and then could be defects, which probably not the case in this case, overproduction. So all these lean principles are violated. And then you can see the people moving back and forth. There is a lots of motions and transportation just to make up the floor manually the way it is today. One option I did propose is remove that gust plate from where it is and bring it to where you need it to be. And that perhaps could reduce some of the motions. You can see the human here, he just need to move whenever he got a new order, which is another piece of 2 by 10 or 2 by 8, whatever that piece is. And then they gust plate it together to make up that. So there's no need for 4 people to move it back and forth and reduce some of the redundancies and motions. The other is also instead of having the drill and the drill person moving back and forth for the length of the floor, some of that could be just put readily available and in a close proximity where the operator is. Use the gravity to the advantage and then get the material come and deliver. So this is, if you can see here, really zero automation, but again, the difference between what you see on the top and in the bottom is probably substantial in terms of efficiency. The concept I advise the companies I work with is fix the people, fix the tools as much as you can. And by this, you can have a better, the word I can say, predictability. So I can, with certainty, I know how long would it take to fasten a joist, a floor joist, or a stud between a top and bottom plate or between the rim boards. If I fix the tools and fix the people, so predictability is the word I'm trying to use. Sue mentioned that you may be able to build a long walls and a short walls. When I discover most of the time, we tend to build a small walls at any time, and we'll build the smaller walls the way we do it on site. And we, in this case, well, if I can build a 50 or 60 feet long wall, why I don't make all my walls 50 or 60 feet so I can put interior walls together? One side of the exterior wall will be long enough, but the side walls, the exterior could be put together. So you can really lump them together. In this case, you can have another predictability in terms of your efficiency and performance. The other part, which is the automation, I build machines which is similar to what you can see from Germany. We have some of those available from Wyman, and I believe there is one in Sweden. So this is the machine I built to be readily available for the North American market, because in North America we use very light framing structure, which is 2 by 4, 2 by 6, 2 by 8, which is really designed for human capacity. So I managed to build the same machine to allow for that. And it's, in this case, you can really fix, you can see here, the machines are fixed, the tools are fixed, and the human almost fixed. They move within a range of a very short travel back and forth. So the machine will do the rest of the work. These machines are readily available, and I'm hoping to start putting that on the market, and just will be putting out my business plan to start looking for funding to make that happen. So this is what is happening today. So if you can see, the tools are fixed, the human is fixed. There's a great understanding of the interaction between the human and the machine, and we can predict how long would it take to frame all the walls in the factory compared to framing on site or in a jig, the way I've seen it in the past. The other one is the light gauge steel. So I built, oops, let me stop the, so the light gauge steel, I built another machine which is really does the same thing for light gauge steel. this bridge here will be used for both light gauge steel installation, sheathing installation, and the plan in a year from now, I'll build a machine that will put drywall, tape the drywall, and potentially sand the drywall as we go. So this is the machine which is really I'm putting together full scale. Will be available for the market soon. The next part is the factory. I try to look at what goes into the wall and what goes into the floor. Am I up? My time is up, Frank. I see you
just
up here.
5 minutes. So if you can wrap
Okay.
it up, we have some time for my apologies.
Oh, I'll be less than that. I'm almost done. So how to make this, to add value to the wall, reduce the number of stations. I have seen factories with a station of 15, 20, or even some places I've seen more than 25 stations, and those taking a lot of space in the factory. So I try to push hard to say, well, why don't we put as much value as we can into the wall and look at the factory, how to design the factory in a way that will become revenue centers for different things. One will do walls, one do floors, one do roof. The way I have seen it in the factories, some of it is already in place. And the last component is the drafting and design. There is a tendency to use, most of the factories we use Revit, which is the predominant software that used in the North American market, but it's the operation is very manual. If you want to produce the shop drawings for the walls, the floors, and all of it, it's really manual operation. Yes, you can see the operators in the front of the screen, in front of a computer, but most of it is manual. Very seldom you find an add-on that will automate the process but again, you don't need it unless you need if you do automation, you need to automate that process. Digitalization of the factory is another items to control. We heard a lot about the quality control, the inspections controls, the pressures, and so on and so forth. The digital world is another, which is readily available. The market is ready for us, and the softwares are available to do all of that. With this, I will stop here, Frank, and conclude my presentation.
Thank you so much, and thanks for trying to be on time. That's great. Such great information, Mohammed. Thank you so much. We do have a few questions. I'll pass it on to Kathleen to moderate that a little bit.
Hi, I see we're almost out of time here, Frank, and Rick has been answering questions throughout. So I thought I'll just highlight a couple. We had a few questions on the inspection process, and that is sort of a multi-pronged approach with factory production. There's in-factory inspections, also on-site inspections and an auditing process. But I would invite everybody to attend our next webinar on code compliance for factory built, and you'll get a lot more detail on the inspection process there. On the sustainability side, there were some questions for Rick on air tightness. I don't know if to speak to that for a moment. Rick, people are asking about typical ACH and blower door tests. Maybe you could just comment a bit on that.
Sure. We build quite a few homes going to different jurisdictions in Western Canada. We don't typically do an air ACH test or blower door test in the factory unless it's required to hit a certification. So we have a builder in the Northwest Territories who is commonly building to Energuide 82, I believe, which needs to hit a 1.2 air exchange. We hit those all the time. We have a number of builders in BC that hit step 4 on the building code, which is 1 or less. And so those are commonly done. We have done some testing in the factory on our standard builds, and typically we're below 2 just with our standard build. So perhaps that'll give people where our blower door tests are typically coming in at.
Great, thanks, Rick. We do have one, I've got one more, I think we've got time to do one more live. We will follow up with everybody that has entered the questions in the chat if we haven't answered you. But there was a question towards the end of the presentation on how the whole system is, how is the system effective towards fire and strong winds? So subject we didn't really cover too much in this one. We did have a previous webinar on modular in the environment, so you might want to take a look at the recording on that. But I wonder, Frank, if you might like to comment on how factory built can
Sure. So, for
resilient.
example, yeah, thank you. So, for example, the slide we had earlier, and I'm going to bring up our last slide here while I'm talking, so that everyone has maybe the website where we have our webinars posted. So for fire safety, for example, we saw an image of multi-unit stores being put together. They come ready with their fire safety fire resistance ratings and assemblies installed. For wind, and I think as Sim mentioned and as Rick just confirmed, sometimes the units, single or modular constructions travel, and for the travel they are essentially, they have all the straps and wind resistance reinforcements that are necessary to survive the trip at 120, well, maybe not 120, but fast speeds around the highway. And so that really is the equivalent of a high wind speed. So they are inherently more wind resistant than your typical code compliant construction on site, which is only built to the code design values. And so the modular builds will then be, in addition to code required values, for the highway, for the travel, for the wind resistance there. So overall, and again, there's more detail in our webinar on the environment, which is posted on the website that you see on the screen now. And I think maybe with that, we'll have to close. It's the time we have to finish early. There's another webinar following us right away. So the deck and recording, again, will be hopefully up by tomorrow. We encourage you to visit all our member factory websites, of course, as well. They're accessible through the CHBA portal. And as Kathleen said, our next webinar is on codes and standards coming up on January 26th. 2023 at the same time, 12 Eastern for 1 hour. And with that, I thank everyone for attending and our presenters. This was a really exciting webinar. Thank you so much, and we'll see you next time.
Frank, about the publication, there are some, I published the work for the invoices. I can pass it on and you can put it in the website.
We'll circulate the questions to all the speakers, and we'll commit to responding to all the questions that we've received. Thank you.
Wonderful. Thank you.